One useful functionality that we can take advantage of in C and C++ is the ability to define constants or macros that will be replaced before our code is compiled. So, for example, we can do one form of a #define or define statement where it defines something, gives it a name, and then lists exactly what that name will be replaced with before our code compiles. So here we've defined hasRaptor flags. It will be replaced with and raptor == raptor. This example uses checking a bit mask to see if this raptor flag has been set to 1 or set to true in that bit mask. So if we had some binary value that represented a bit mask with flags, then we write hasRaptor flags after the variable name, and it will become the statement myFlags and raptor == raptor to check if that bit was set. We could do the exact same behavior using parameters and make this look a little more like a function. So we give it some parameter v, which is just a name, and then whatever is given to the hasRaptor flags macro will be put in place of v, and then the full statement will be put in place of hasRaptor flags, myFlags. So it will come out to the exact same thing as above, myFlags and raptor == raptor being the condition of this if statement. So let's break down the pieces of a define statement. There is, of course, the #define keyword part of it, then the name of that new macro. It can use all the same rules as variable names, function names, etc. The convention is to use only uppercase characters and to put underscores between words inside of that macro name. Then we could give it a set of parameters, a list of parameters. They would be separated by commas if you had more than one. It's really just a list of variable names. The convention is to name them the same as your normal variables or parameters, but you'll notice that there's no type specified for them. It just stands for some text that will be supplied when our macro is called. This also means there will not be type checking done on the macro until its replacement has been done and our code goes to compile. That means that the text could be pretty much anything and could even include spaces inside of there. It gets a little crazy really fast. So then we have finally the text that will replace the macro invocation. We could put parentheses around it. That does help to make it clearer which part is which here. It's really just a straightforward text substitution, except we need to know what will be our v or our other parameters to replace there, and then the full statement will replace wherever this macro was invoked. And if the macro uses other macros, then those will be expanded first before the replacement is done. If we do a \/ at the end of a line, that's treated as a space so that we can do multi-line macros. If we use the # inside of the macro's replacement portion here, that would surround the variable's text value with double quotes, meaning to turn something to a string literal. And 2 # will stick together text without any spaces between. This could be done to create a variable name, for example, where you might be saying you want it to be int with some name so that it gives it a descriptive name of what that thing was when the code is compiled. So one example that we might use these in is conditional compilation. If we wanted to define code that only happened when we're debugging, then we can define debugging to be true, or to exist rather, and then we can ask if it is defined. People often use this too to make sure that the same file doesn't get included multiple times. If it's already been included, skip the line that would have included it, things like that. This allows us to have sections of code that get disabled or enabled based on these different things that we've set up in our macros there. The -d flag can be used in the compiler to define things like these as well. Another use would be defining simple constants. We might want to use pi all throughout our program rather than having to write variables for it and make those somehow global or things like that. We could just define pi as a macro, and wherever we write pi, capital P-I, it will be replaced by the exact value that we've written in to be used for pi in our program. It's just an alternate way of defining constants in one respect, but it is not type safe. It will just be replaced in exactly as it is, and then your errors will get caught later in the compilation process. You also should make sure not to add semicolons at the end, or it will put that semicolon in the middle of statements when you use pi or whatever your constant is in the middle of a statement. Another really common use of the define statement or macros is when we have something that's platform specific about our programs. If there's a thing that Windows does differently than OS X or does differently than Linux, we can define things specific to those operating systems because our compiler will have some values set that we could detect there and change things around a little bit. So it's especially helpful for when we're linking in different libraries or things like that in different operating systems too. It can also be used in some ways to simplify our code. If there's a common structure that we're using all throughout the place, like a loop through different XML child nodes, starting from some root node and going through all of the nodes that exist there, then we can write a macro for that so that later on in our code, we're then able to just start ourselves off at the root, and it will go ahead and go through all of those. This could be really helpful for something like a loop through a linked list as well, for example. You just provided the head of that linked list and it could keep going through it. We also can use macros to define new constructs in our code with a little bit of shorthand, sort of. So, for example, here we're declaring a string variable that would have the value of the type name so that I could do things like creating a new class that gets a string that describes what it is and then an actual class definition here, or at least the declaration for it, where it declares it to be my class because that was what was given as the first parameter there, and it even declares it to inherit from a particular parent class. This would be one way you could do stuff that we did with generics a little more easily. We could create an int vector or string vector or that kind of thing by defining a macro that just took the vector class and put string or int in those various places where it's needed, and it would have a descriptive name when it gets to the compiler that would make it a string vector or int vector or that kind of thing. One often used very handy macro is defining debug printing so that when you go to actually make production versions of your code, it does nothing in those cases, but when we make the debug versions to test out, then that output command there will actually call to the right things to feed out this data. So you could write in the print statements normally using this macro definition. It would set it up as a cout statement just like you would expect, but when we're not in debug mode, it would not print out anything there. It would not replace that with anything. It would replace it with nothing, in fact. And then in your make file, you can just enable that debug output by using the right flag for it. So those are just a few examples of what you could do with define statements or macros in C or C++. It is a little looser with some things, as we saw with the types and with doing things like inserting semicolons or literally anything you put in that macro being inserted into your code, but it can do neat things like allowing different behavior in different settings, or like writing quick shorthands for coming up with different variables or classes or things like that.